Let's spend some time looking at package management within Red Hat Enterprise Linux 6. There are a number of methods to manage packages on your system, one of which is RPM, which we'll be looking at in this particular area. So let's label this section Package Management with RPM. This is the traditional means of managing packages within Red Hat Linux and is still supported, although seemingly being deprecated, but nonetheless is still a useful means of managing packages on your system. Now, a number of features are provided by RPM, including compression of packages, which means the full size of a package is not reflected during transit or on the storage medium, such as a CD or DVD, meaning that during installation a package is decompressed on the fly and the full size is reflected on your system. So during transit, whether across the internet or via storage medium, the full size of the package is not realized or reflected, which is a good thing, which means you can stuff more packages onto a particular medium or transfer across the internet in a more timely fashion. So compression is inherent, has always been, and continues to be. Currently they're using the XC lossless compression technique, which is faster on the decompression side and provides superior compression to the prior method. In addition, packages are signed with a strong SHA-256 hash. So SHA-256 hashes are used to sign packages, which differs from Red Hat Enterprise Linux 5, which is why the RPM versions are not compatible. However, it's good to know that the packages are signed with a longer string or a longer or greater bit length, rendering a more secure package as a consequence. So when you confirm your SHA-256 strings using any of the verification techniques, you know that you're basing your confirmation on 256 bits of a particular algorithm, in this case SHA. RPM maintains a database in varlib RPM. This is where it stores information that it tracks, such as the packages that are installed on your system, so it tracks installed packages, as well as attributes of the various packages and the corresponding files, etc. So the database is used to track all of this information, just exactly what is installed on the system and all of the files associated with those packages and attributes associated with the contained files, so that you can perform proper verifications. And we'll show you some examples of verifications momentarily. RPM operates in 5 modes. So 5 modes of operation, and they include installation mode, which is perhaps the most natural to understand and appreciate because it allows you to install packages, RPMs, on your system, providing, of course, the supplier of your application supplies RPMs. Not all suppliers provide RPMs. However, the platform is readily open and anyone can roll their packages, let's say their traditional tar-gz images, as RPM files. So you can install packages. Conversely, you may uninstall packages. You may also upgrade. You may query the database as well as files on the file system. And you may also verify packages, which allows us to determine whether or not there are discrepancies between the RPM database's view of the file or file system and packages and what's actually there on the file system. So for example, supposing you have LFTP installed and one of its key files, let's say the binary file, has been usurped. Using the verification technique of RPM, you could determine whether or not the signatures match. So the version of LFTP on the file system may differ from the signature provided in the RPM database, which would reflect some sort of tampering or discrepancy that's worthy of investigation. So you have a means of determining whether or not the integrity of your system is sound or reflects your pristine state. So these are the 5 modes of operation. Now let's just note as another feature and as also a caveat that RPM does not automatically resolve dependencies. And for that, you should use yum, which we'll be looking at as well, to resolve dependencies. So for example, supposing you wanted to install, let's say, a package that requires many x.org and GNOME libraries. By default, if you attempt to use RPM to install that package using either the install or the upgrade option, RPM will complain that there are unmet dependencies, but it will provide no course of action to rectify those discrepancies. So that's one of the downsides of using RPM, and that is you're not able to automatically resolve dependencies, which will relegate you to using another tool such as yum, or perhaps resolving manually the dependencies, which can be quite time-consuming, to say the least. So let's march through the various modes of operation. So the first mode we'll explore is the query mode. This is a natural mode to explore because a number of packages have been installed post-installation or as a consequence. So that means there's a lot that we can query without compounding matters even more, meaning installing more packages. So it's a good thing to start by querying what exists on the system. We often reference throughout our studies RPM query all. This is a simple command. Q is query that enters query mode. A means all, which instructs RPM to dump all of the packages that it knows of that have been installed on the system. So dumps all installed packages. And by packages we mean RPMs, not third-party non-RPMs such as targz or tarbz2 images. Those sorts of programs will not be tracked by RPM. Let's just note that as well. 6, another caveat. RPM does not track non-RPM programs or apps, i.e. programs that are named star.tar.gz or star.tar.bz2, etc. So if you obtain packages of those forms, RPM will not track them. So long as you have a means of keeping track of them, that's okay as well, because there are a number of packages that are available online, open source, that provide no RPMs. But since RPM targets one of the major Linux platforms, you'll more than likely find an RPM for your particular platform, Enterprise 5, 4, 3, 6, SUSE, or perhaps Debian packages or Ubuntu packages, which are one and the same. So with that said, query all will allow us to enumerate what's on the system. Now it helps to use query all in conjunction with grep or less in search of specific packages. Now you need not be the root user to run query all. Any user can query the list of packages installed on the system. When you query all of the packages are dumped, their names. Their names always include the platform, and they're tied to the platform on which they're installed. So our system's 32-bit x86, and as a consequence the packages are 686 packages, as opposed to x86_64 for 64-bit packages. This dump ran by pretty quickly, so we're not able to take full advantage of the output. If we pipe the output into less, for example, we'll see one page full at a time. It's currently not sorted alphabetically, but these are indeed the packages. These are RPMs that were installed from the original media, across the wire, or from DVD. So query all dumps the packages. Used in conjunction with grep makes it a little bit more useful. So supposing you're in search of, let's say, the package that contains grep, which happens to be named grep. You can grep the entire dump in search of grep. You now know that grep is owned by the package named grep. Now let's take this package name and analyze it briefly just so that you have a sense for what is standard within RPM packages. So as another example, we did RPM query all grep grep, and this returned the following. So this package owns grep. Now when you see a package, its name resembles the following. To the left of all the numbers and platform information is the unique name of the package. So this is the unique name of the package. To the right of the unique name of the package is version-specific information. So this is version 263 minor 2 for EL6 i686. So in this name there's a lot of information. Grep tells us main name of package, 2.6.3-2 package version, and EL6.i686 includes 2 pieces of information. Let's just include an extra 6, including the version of Red Hat, so Red Hat version, and platform. In our case, i686, which means 32-bit. So that is how you are to parse package names when you see them. This becomes important because as you attempt to get more information about packages, you'll invariably reference the main name of the package and not the version information, which follows, everything to the right of the hyphen. So wanting to find out more information about grep, you just specify grep in your RPM query searches. So let's extend this a bit. So RPM query, now instead of querying the entire database, which could be hundreds or is hundreds of packages, and in fact let's just confirm it, RPM query all, pipe the output into the word count utility and then list the number of lines returned, and there are 1151 packages. So instead of enumerating through all 1151, we'll simply query directly the grep package. Now it's not enough to just query. You need to tell the query what to do. So you're either going to query all or you're going to query specific things. For example, supposing you wanted metadata about the package grep. RPM query I followed by grep, which is the main name of the package, will return that metadata. So returns metadata about grep package. The metadata contain information such as the name of the package, the version, the platform, the system on which it was compiled, whether or not it has a signature associated with it, a description, and so on. So it tells you about the package, useful information about the package. Let's try this, and you don't need to be root in order to find out information about installed packages, because this is considered to be information that is not harmful. So RPM with the query I option for installed packages shows us information we've mentioned. This is the main name of the package, this is the version, this is the release 2.el6 for the platform EL6. It was installed on this particular date, that's when the system was installed. It belongs to a group named applications/text. This is its size. So this appears to be 786,869 bytes. How it's licensed, the source RPM from which it came, the build host, when it was built, the vendor of the package, in this case it's one of the source packages from Red Hat, not from a third party, the signature associated with the package, key ID, GPG is used to sign the packages, the packager, URL information about the package so you can learn more about it. It's a GNU program. And a summary and description as mentioned. So query information will return information about or metadata about packages that are specified. That's the query I option, which is a submode of the query option. Now to stretch this a bit, supposing you wanted to enumerate the contents of this grep package, rpm query list followed by the main name of the package enumerates the contents of the package grep. As mentioned, a package is a compressed item, so it's in essence like a tarball because all of the files and or directories are rolled into one file known as an RPM, but when expanded it explodes into one or more directories and one or more files. For the most part, all packages contain more than one file, in fact a series of files, because typically documentation, config files, binaries are included with packages. They're all rolled into one big package. So here's an RPM query list on grep. This will enumerate all of the files included within the grep package. So within grep, we expect that there are three binaries: egrep, fgrep, extended grep, fgrep, grep, documentation and user share doc, grep for the version, readme, so on, locale information for various languages, an info page so that you can use info to learn more about grep and its usage, and man pages for egrep, fgrep, and grep. So again, the binaries that are of interest are outlined first. They're in bin, and if we lsl bin star grep star, we see the three items. And if you turn on, for example, the inodes, you see that there are three distinct inodes, indicating that there are three distinct binaries instead of symlinks or hard links to the same inode. So they're not the same binary in this particular case. Grep and egrep are similar, but they're not the same in this particular case. So rpm query list enumerates the contents of a package, and again, it's a useful option in the event that you've forgotten or would simply like to be refreshed about what's contained within a package. Now, there's another type of query that we can perform. Now, there are a number of binary files included on a standard Nix-based system. So supposing you've forgotten the name of a package to which a binary belongs. For grep, it's quite obvious. We've already searched it. We know it belongs to grep. But it's now months later and you're using certain binaries and you'd just like to check to which package they belong, because let's say you intend to upgrade the package or reinstall it because you think there's some sort of corruption and just need to know more about the package or the file's membership to a package. So using the query option still, we can now reference a file followed by its name, such as bin grep, and this will cause RPM to tell us to which package the file belongs. So enumerates the file's package membership. And this is a quite useful option that I use quite often because it's not always easy to keep track of which packages files belong to. So we've forgotten that grep belongs to a package named grep. So if we query file bin grep, we're told that bin grep belongs to the grep package. And ditto, of course, for egrep as well as fgrep and any other file that belongs to grep, including the documentation and so on, the locales files, etc. So query file with the F option will reveal the file's membership to a particular package. Now supposing we want even more information, such as, let's say we want to see the documentation that a package contains. There's an option certainly for that as well. Query docs. So if we query using the D option, the name of the package, grep, this enumerates the included documentation, which can be quite important if you just want to extract that bit of information from the package as opposed to all of the contents of the package. So it's a subset. It's like doing a grep for documentation. So now we see that all of the documentation included with the RPM with respect to grep is contained within the following files: man pages for each of the binaries, an info page for grep, and user share doc grep and its 2.6.3 version. So you can search for documentation using the D option. So just a quick recap. I gives us metadata. L lists the contents of a package, including files and or directories. F shows us to which package a particular file belongs to. And D enumerates documentation that is contained with a particular file. There's yet another option that may be of use to you. RPM, supposing you wanted to see configuration files that belong to a particular package. The C option will do that. Now, that of course will only work if a package contains configuration files. So it enumerates a package's configuration file, or files if more than one. Usually packages reference one configuration file and a subdirectory .d where you may place multiple config files. So let's take a look to see if grep includes any config files. As we can see, it doesn't. The exit status is okay because RPM did its job. But we know of a package that includes a config file. LFTP comes to mind, the main lftp.conf file. So notice this query for LFTP returns that LFTP relies upon etc lftp.conf for system-wide settings that are defined whenever a user by default enters LFTP. And similarly, the other queries would work that we've performed against grep for LFTP. So here are the documents for LFTP. LFTP, get, there's even a documentation file for the config file so that you can learn more about the configuration directives. And a top